All right, so we're starting our first official unit, which is reaction kinetics. And there's going to be 3 lessons for this unit. The first lesson is on reaction rates. So just sort of an introduction for you so you know sort of where we're coming from with this is that in Chem 11, you learn that there's different types of chemical reactions. And now you're going to learn what's happening at the molecular level to drive the chemical reactions. And in this unit specifically, we're going to be learning about the rates and mechanisms of chemical reactions. So this first lesson is going to be all about reaction rates. And we're going to start it with measuring reaction rates. So what are the things that we can use to measure the rate of a reaction? So when you're measuring the rate of a reaction, it is always quantified per unit of time. So it'll be per second or per hour or per minute because we're talking about the speed of the reaction. So some of examples that you could use for reaction rates would be a change in amount over time, or an amount of reactant consumed over time, or an amount of product formed over time. So the first thing we're going to practice is just writing different rates of reaction. So for example, if I told you that 16 grams of hydrochloric acid are used up in a reaction in 12 minutes, what would be the reaction rate? Well, it would be the grams of hydrochloric acid used up. So it'd be the amount of reactant consumed over the time, which is 12 minutes. So we would simply write 16 grams of hydrochloric acid in 12 minutes. And then you would actually just type it into your calculator. So you grab your calculator and go 16 divided by 12, which is going to give you to 2 sig figs, 1.3. And then the units would be grams per minute of hydrochloric acid consumed. Now, there's lots of ways, to write it. If you just wrote 1.3 grams per minute, that's the reaction rate. If you want to describe what reaction rate you're looking at, you could write 1.3 grams of hydrochloric acid per minute or 1.3 grams per minute of hydrochloric acid consumed. There's lots of different answers, but the key thing I'm going to be looking for is that you know what your units for the rate are. So for this one, it was grams per minute. All right, pause the video, give the next one a go. So for this one, it says that calcium carbonate was reacting with hydrochloric acid, producing 245 milliliters of carbon dioxide in 17 seconds. So this is looking about an amount of product formed over time. So for this one, it's 245. My fours always look funky. Oh, there we go. 245 milliliters of carbon dioxide in 17 seconds. So again, you just plug this into your calculator, 245 divided by 17, and your answer to 2 sig figs this time would be 14 milliliters per second of carbon dioxide. Or again, you could say 14 milliliters of carbon dioxide is produced per second, or something along those lines. But the big thing is that the units for rate changed. We're no longer grams per minute. Now we're milliliters per second. The next thing we're going to cover on how to do is how to convert your units of reaction rates using dimensional analysis. So for example, if I gave you that the rate of zinc consumed or produced is at a rate of 0.26 moles per minute, and we wanted this to be in grams per second, we have to convert these units, moles per minute, into grams per second. So what we're going to do is we're going to set it up by putting 0.26 moles of zinc in 1 minute. And then we're going to convert our units. So now I'm going to do this in one big dimensional analysis. If you wanted to do it in 2 separate steps, that would be fine as well. But the first thing I'm going to do is convert my moles. I want to convert from moles into grams. Moles is on the top, so I'm going to put moles on the bottom, where I know that 1 mole of zinc weighs how much? Well, you're going to go to your data package and you're going to look up zinc, which I'm currently doing and I'm hoping you're doing as well. I'm going to find that it is atomic number 30 and it has a molar mass of 65.38. So 65.38 grams per mole is the molar mass of zinc. And then the next thing I'm going to do is convert from minutes into seconds. So I'm going to put minutes on the top, so I'm getting rid of minutes, and I'm going to put seconds on the bottom. And I know that 1 minute is 60 seconds. So then in my calculator, I'm going to type in 0.26 times 65.38 divided by 60. And my answer to 2 sig figs would be 0.28 grams per second. And you know that you're in grams per second because, again, we're analyzing the dimensions. So we've gone from moles of zinc into grams of zinc. We've gone from minutes into seconds. So we're left with grams per second. All right, pause the video. Give the next one a go. So for this one, we're doing 3.0 grams of oxygen per second, and we want to convert it to moles per minute. So what we're going to look at is we're going to go from grams into moles. So we're going to put grams on the bottom. We're going to put moles on the top. And we're going to say that 1 mole of oxygen, now the oxygen, there's 2 oxygens, so it's going to be 2 times the 16, right? So the molar mass of 2 oxygens is 32. And then again, we're going to convert from seconds, well, this time seconds into minutes instead of minutes into seconds. Seconds on the bottom, I'm going to put it on the top. I'm going to say that 1 minute is 60 seconds. And then we're going to plug that into our calculator. So 3 divided by 32 times 60 would leave us to 2 sig figs, 5.6, and the units I'm now in is moles per minute. And again, this is of oxygen. You could put it in there, but what I'm really looking for is that you understand what the units that we've converted to are. All right, this last one. Magnesium is consumed in a reaction at a rate of 0.034 grams per second. Calculate the number of moles of magnesium consumed in 6 minutes. Now, there's more than one way of doing this. Some people will start with this 0.034 grams per second, and then what we want to do is calculate or convert that into moles. Or some people will start with the fact that we know we have 6 minutes. So it's kind of up to you. There's quite a few questions of these to practice in Hebden, and I do recommend doing these. So again, you can start with, because we've started all of them, with this ratio idea, or you can start with the amount of minutes that you have. I've done it both ways, and I'll probably teach it one way one day and then do it the other way another day. But I feel like because we're on this roll of starting with the conversion or the rate, I'm going to start with the rate. So I'm going to say that 0.034 for some reason, it just hates to erase. Don't do that. Okay. Here, wait 1 sec. There we go. Sometimes if I just use Edge instead of Adobe, it works better. So, okay, I'm going to start with 0.034 grams of magnesium is used per second, and I want to convert this just to moles. So no unit of time and not grams. So it's up to me what I want to switch first. So I could switch from grams to moles first, which maybe that's what I'm going to start to do. So I'm going to go from grams to moles. So my grams is going to go on the bottom, my moles is going to go on the top. And I'm going to look it up, and I know that 1 mole of magnesium weighs 24.31 grams. And again, you're just going to your formula sheet. It's atomic number 12, and you're looking that up. So now I'm in moles of magnesium. Okay, so I've gone from grams to moles. Now I need to get rid of the seconds. So I know that magnesium, I want to find out how much magnesium is consumed in 6 minutes. So up to you, you can change 6 minutes into seconds, or you could do a conversion from seconds into minutes. So we know that 1 minute is 60 seconds. So now, right now, if we look at the dimensions, what am I in? Okay, I've gone from grams to moles. I've gone from seconds to minute. So now I know that this is my rate of magnesium consumed in moles per minute. So then the last thing I'm going to do is just multiply this by the 6 minutes. And then I know that I've converted just to moles. So the only thing left is going to be moles of magnesium. So I'm going to plug this into my calculator. And I get 0.034 divided by 24.31 times 60 times 6. And to 2 sig figs, I'm going to get 0.50 moles of magnesium would be consumed. All right, so hopefully that felt good. So now what you're going to do is go to your learning assessment. Start with the Hebden questions. There's really nice detailed solutions to the Hebden questions, and then try the questions that I've supplied after. And if you can do all of those, then you understand what's going on. Good luck.